This is chapter 8.6 with a focus on solving exponential equations. Before we solve an exponential equations, we need to review that change of base formula for logarithms, because this will help us to solve for these exponential functions. So when we have a change of base formula, a base other than 10 or e, which are the only bases that our calculators will do, we have this formula that says log base u of v will basically turn into log of v divided by the log of u. And as long as we pick the same base for both the numerator and the denominator, we will come up with the right answer. So if we're smart about this, we will pick either log v or natural log, because those are the buttons that we have on our calculator. So we want to be smart about this. So for example, log base 3 of 5, we're going to take log of 5, and the way I remember this is the 5 is higher, and so the 5 is what's going to go in the numerator, and then the 3 is closer to the bottom, so it kind of, I think of it as dropping to the bottom. So the 5 is what's on top, the 3 becomes the bottom, and when we have two logarithms then in our calculator, we'll type it in and do log 5 divided by log 3, and we'll get our decimal answer of approximately 1.465. And so we'll always round off to 3 places. We can also use a natural logarithm, so I encourage you to type in with a natural log, and as long as you use the same button for both the numerator and the denominator, you should get the same decimal. So just to kind of prove our point here, I'll do the second example here with the natural logarithm. So this will become natural log of 4 divided by natural log of 6. And we'll type that into our calculator, and we'll get our answer. And it turns out to be approximately 0.774. And we'll round it to 3 places. And for the last one, just to give it a good try, we'll use log 20, and then the 5 is closer to the bottom, so it becomes the bottom of our fraction, and we'll type it into our calculator. And I encourage you again to use the natural log just to really prove that you do get the same decimal answer. 1.861 is our answer. So that's how we use our change of base formula. Now we're going to solve an exponential function, and the rule with solving exponential functions is that once we get the base alone, so that's going to be step 1, get the base alone. Step 2 will be to put it into log form. So for example, number 1, the base is already alone. That's my base. And so now we're going to put it into log form. So if you guys recall, if I have log base b of x equals y, the way I'm going to change this into exponent form is I say b to the y equals x. Well, if I need to go backwards, then the base of the exponent, the b, is going to become the base of the log. So it'll look like this. Log base 2, and then of x. Well, x is over on the other side. So we'll start with the b, log base 2 of 18, and then we should always circle around that equal sign. Equals x, which should always be set equal to the exponent. Whatever the exponent is, that's what my log is set equal to. And so now we have x alone, and I'm ready to use that change of base formula, so I'll use the natural log here. Natural log of 18 divided by natural log of 2. And when I type it into my calculator, I get approximately 4.170. I'm going to round to 3 places, and that's my answer for x. So again, my steps for solving an exponential function are first and foremost to get that base alone. So I'm going to identify the base. Here it is 3. And so I need to clear away anything added, subtracted, or multiplied, or divided with that base. So here I have a minus 5. So the first thing I'm going to do is go plus 5 to both sides, and that gets my base, 3 to the 2x equals 19. My base is now alone, and so now I'm going to put it into log form. So I'm going to write log, and then the base becomes the base of the log. So log base 3 of 19 equals 2x. Once I have it in log form, I'm going to use that change of base, log 19 divided by log 3, and I'm going to put it into my calculator, and I get approximately 2.680 equals 2x. And now here x is not quite alone, so I need to do one more step to get my x alone, and that is to divide away that 2. So ultimately I get approximately 1.340 is what x is approximately equal to. So again, here's another exponential function. This time our base is the base e, but remember, e is a number. Just like any other number, it's its own number. So that is my base. So before I can begin, again, I need to get the base alone. So I need to divide away the 2. And I get e to the x equals 9. And so at this point, I'm going to put it into logarithm form. So I'm going to say log, and then the base of my exponent, whatever that base is, in this case e, becomes the base of my logarithm. So log base e of 9 equals x. Circle around that x, that equal sign. And so now I have two ways to go about this. If I remember that log base e is the same as the natural log, then what I can do is I can rewrite this as the natural log of 9 equals x. And if I do that, then it's really easy to just plug it right into my calculator, and I get my answer. 2.197 is approximately what x is equal to. That's one way to do it. But not everybody's going to remember that right off the bat. So if you forget that that's natural log, you're going to take it and put it into log, use that change of base, and you're going to go like this: log of 9 divided by log of e, and you should get approximately the same exact answer, approximately 2.197 equals x. Okay, so if you forget that it's the natural log, just use your change of base. You should get the right answer. So one last example here. Again, it's base e, and again we need to get that x, or get that base alone. So here I'm going to go plus 5 again, and I get e to the x plus 1 equals 19. Put it into log form. So we have log base e of 19 equals x plus 1. And again, I can either remember that this is the same as the natural log of 19, and then I can type it right into my calculator that way. And then I have one last step, minus 1, minus 1. And so this way I get x is approximately, remember we rounded, 1.944. But if I forgot that that log base e is the natural log, I can just use my change of base, log 19 over log e, type that into my calculator, and it should end up being the exact same number with the exact same equation. We should get the same answer regardless of how we do it.
Made with Doodlecast Pro.